A salt E is common ammonium chloride. So it is NH4 and Cl. That's the name of the salt. Describe the appearance. It does not contain a transition metal, non-transition element. So what will be the appearance? So 1 mark is for mentioning white. If it was a solution, then you will mention clear solution. But because it is a salt, which is not a solution here, so it is a white solid. Then using a spatula, salt E was placed in a hard glass test tube. Inside the top of a test tube was suspended a piece of damp litmus paper next to a piece of damp blue litmus next to a piece of damp red litmus. E was gently heated until a gas come out and red litmus went blue, then blue litmus went red. So basically what is showing? It is showing that acidic and alkaline gases are given off. And because it is ammonium chloride, so this can result in formation of ammonia gas and hydrogen chloride gas. Then E was dissolved in water to make an aqueous solution. So we make a solution. To the first portion, we add few drops of nitric acid followed by silver nitrate. So that is a test for halide ion chloride, bromide and iodide. What is the observation? And we already know this is ammonium chloride. So what will be the observation? It will be white precipitate. To the second portion of a solution was added lead nitrate. Lead nitrate is also a test for halide ion, chloride, bromide or iodide, because we can use silver nitrate or lead nitrate to test these halide ions. What will be the observation again? So this will also give white PPT or white precipitate. To the third portion was added about sodium hydroxide and a mixture was heated. When we add sodium hydroxide and heat, that is a test for ammonium ion. So what is the observation when already we know there is ammonium ion? So what we'll observe? We'll observe a pungent gas which will turn red litmus blue. Because that's alkaline gas, ammonia is released on adding sodium hydroxide. Name the gas given off in test C3. Which gas is given off here? Yeah, ammonia is there. Ion is ammonium, but gas is ammonia. But you don't have to write a formula. You have to write the name of the gas. So the gas which is released or given off is ammonia. Explain the observation in test B. So what this test B indicates, red litmus went blue and then blue litmus went red. So what it shows acidic and alkaline gases are which convert blue litmus red, and the alkaline gas is given off which convert red litmus blue. Is it clear? So in this question 5, two calcium compounds C and D were tested. C is partially soluble and D is soluble in water, dissolve. The mixture C and D were added and the mixture was filtered. The filtrate. So filtrate, majority inside the filtrate will be D and it will have some C. Why it will have some C? Because C is partially soluble. So the filtrate will have some C as well. But both are the calcium salt. What else with calcium we don't know. The filtrate was divided into 5 equal portions. To the first portion, we add aqueous sodium hydroxide little at a time, means 5 drops or small amount. What is the observation? If there's a calcium ion, if there's a calcium ion and we are adding few drops of sodium hydroxide, so it will give white PPT or white precipitate. If we add an excess, what we will observe? The precipitate does not dissolve in excess. And to the second portion, we add aqueous ammonia, little at a time. When calcium salt is there, so there is no visible change or no change or no visible change or no reaction. With calcium, aqueous ammonia, there is no visible change or no reaction. To the third portion, we add sodium hydroxide and aluminum powder. So sodium hydroxide and aluminum powder, that is a test for nitrate ion. And a paper red litmus turn blue because of ammonia. Gas releases ammonia and the ion which is present is nitrate. So, and we know all nitrates are soluble. So compound D is calcium nitrate. How we conclude compound D is calcium nitrate? Because they mentioned D is soluble and all nitrates are soluble. So that's why D should be calcium nitrate. The pH of the fourth portion, and it is about 10. So if it is about 10, it means pH 10 means it is making an alkaline solution. And why it will be alkaline? Because of hydroxide. So basically, what it means the C was calcium hydroxide. Carbon dioxide is bubble and aqueous calcium hydroxide was there. Carbon dioxide is bubble. The lime water, because in the presence of carbon dioxide, will turn milky. So that shows that C was actually a lime water or calcium hydroxide. Name the gas given off in A3. Which gas is given off here? Which turned the red litmus blue? Ammonia is there. In exam, when you mention, you will mention specific the term instead of formula. So you will mention here ammonia. Suggest an explanation for observation in A5. A5 basically because it is lime water, that is why it turned. Aqueous calcium hydroxide which turned milky due to formation of calcium carbonate by reacting with carbon dioxide. You have to explain the observation. Then what conclusion can you draw about the identity of the anions? Anion means the negative ion. So what anion is present in C and what anion is present? D is a soluble, and we know all nitrates are soluble, so it completely gives an idea that D is nitrate. And C is partially soluble, so when we work out, because it's a basic solution, so it is hydroxide. So one is calcium hydroxide, and but we just have to mention the identity of the anion. So we can mention C contain OH ion or hydroxide ion, and D contain nitrate ion. In C we have hydroxide ion, and for D we have nitrate ion. In this question, a sample of solution of acid A was analyzed. Test on A and sub of the observation. So A is an acid. The pH of the solution was tested with indicator pH 4. So what this gives an idea? The type of acid, strong or weak? pH 4. It's a weak acid. Then the solution was divided into 3 test tubes. To the first portion was added a piece of magnesium. When acid react with metal magnesium here, it will give salt and hydrogen. So the gas tested with a lighted splint. So what we'll observe fizz, bubbles, effervescence, and lighted splint, it will give a pop sound. To the second, added sodium carbonate. So when carbonate is added to acid and the gas was tested with the lime water, so again it will give fizz, bubbles, effervescence, and the lime water will turn milky. To the third portion of liquid A was added spatula of B. The mixture was boiled by using a teat pipette or a dropper. By using in observation, you cannot write the name of the gas. You just mention what you will see. You cannot write like carbon dioxide or hydrogen gas is given up. That is not correct. By using a teat pipette, solution was transferred into test tube, another test tube. The excess of aqueous ammonia was added, and you observe dark blue solution or deep blue solution. What this gives an idea? Which ion is present? Copper. What does the test A tell about the type of acid in A? So what test A indicate when the pH was 4? It shows that it is a weak acid. Name the gas given off in test B1. Which gas is given off here in B1? When you add acid to magnesium, hydrogen. And which gas is given off in B2? When you add sodium carbonate to acid, carbon dioxide. Explain the observation in test B3. Look, it is forming a colored solution, so it means there is a transition element. Contain a transition element. And which transition element is there? That is copper. And you have to write the valency as well, copper 2. So only copper will not give you mark. You should write the valency as well. 2 plus or plus 2. Both ways, it is right. In this question, a solid compound X was analyzed. Solid X is aluminium salt. So we know aluminium, but what else is there with aluminium? We don't know. So it's an aluminium salt. One spatula of measure X was placed in a hard glass test tube. A solid was heated gently, then strongly. The gas was tested with a pH indicator. The paper went red and the condensation at the top. So when there is a condensation at the top, it means it is a hydrated salt or contain water of crystallization. And paper went red means some acidic gas is given off. Distilled water was added to X and it was divided into 5 portions. Aluminium salt is there and this aluminium salt is divided into 5 portions. To the first portion, we add excess of aqueous sodium hydroxide. What we'll observe if we add sodium hydroxide? First drops and then excess, and aluminium salt is there. So what we will observe? First it will give white PPT, and then in excess, what happened to precipitate? The precipitate dissolved to form colorless solution. To the second portion, we add aqueous ammonia. If we add aqueous ammonia, what will be the observation? So it will give white PPT. So in the beginning, the first is white PPT. Now in excess, if we add more than enough ammonia, will the precipitate dissolve or remain insoluble? In excess of aqueous ammonia. To the third portion, we add hydrochloric acid followed by barium chloride. This is a test for sulfate ion. And we do not observe any visible change. So it means there is no sulfate ion present. To the fourth portion, we add nitric acid followed by lead nitrate. This is a test for halide, chloride, bromide or iodide. If no visible change, it means there is no halide, no chloride, bromide or iodide. And to the fifth portion, sodium hydroxide and aluminum powder. This is a test for nitrate ion. So a pungent gas is an ammonia gas. So this confirms that this salt contains gas is ammonia and the ion which is present is a nitrate ion. So we can conclude that this is actually aluminum nitrate salt. So what does test A tell you about the gas given off? So acidic gas is given off because the pH paper turned red. What conclusion can you draw about X from test B2, B3 and B4? So B3 shows that there is no sulfate and B4 shows there is no halide. Identify the gas given off in B5. That gas is ammonia. What conclusion you draw about substance X? What is substance X? It's of 2 marks. So 1 mark is for mentioning hydrated and aluminium. Aluminium will not give you mark because that's already mentioned in the question. The second part is nitrate. So it is hydrated aluminium nitrate. Is it clear? The identification, these are some questions which I discussed too. So you have to learn the table for identification of the ions. Any question related to the class? Okay, I will end the session and share this with you.